Okay, so let's have a look at what we're talking about here. So if I was to look from above or even below, it's some solid. So it says its base is x squared plus y squared equals to 9, which is a circle centered at the origin with a radius of 3. So its base is circular, okay? But if we were to slice it, we should always get we'll do part A first. We should always get a square cross section. So that means like if I slice it down here, of course, the square is going to be biggest here because this is where it's got the longest distance here. So whatever this distance is, that's going to be the height. Kind of. It's kind of like a cylinder. I'm trying to draw this thing here. It's kind of like something like this. It should come to a point in front because notice right here, it's going to have a very small square. See, so that square is very small, then the squares get bigger. See, I'm trying to picture something like this. It's a bunch of these stacked together. So it's kind of like a cylinder, kind of like where the sides like this are shaved a bit, okay? And then it will get, I think they'll show you a picture of it in the, so yeah, it kind of comes like this, and then it kind of domes. So more from the sides, you're going to see it like that. All right. So here's the thing. So it makes it very tough to visualize what this volume is. So the key thing is to understand what are we summing up? Because before we were always summing up flat cylinders. Now what we're summing up are very flat prisms. I kind of consider them like plates that we're putting in, very thin, like a square plate or a triangular plate. So basically what we're being told is if you slice it this way, perpendicular to the X. So what I do is I always draw my slice as a rectangle. You good, man. So if I slice it like this, and then look at it, I should see a square plate with a very, very thin square plate. That's what I'm summing up now. So it's not generated by revolving, it's just there, and it's just by stacking a bunch of square plates, and their height is equivalent to whatever the length of the rectangle is. So notice it's going to be taller in the middle. It's going to be shorter as we go out. That's why I'm trying to show it kind of coming in like this. So now all we got to do is figure out what the volume is of these plates. Because if we get one plate, we know we're going to just sum that volume up from -3 to 3. So it's going to be the volume, our volume on these is going to be from -3 to 3, and it's going to be whatever the volume of a prism is. Those are prisms. So I just got to figure out how to write that volume of a prism. And of course there has to be a dy or dx in there somewhere. Yes, yeah. So the slice tells you the dx. This, again, since the rectangle's width is a change in x, that will end up being our dx. So now let's see how to get the volume of a prism. So all prisms have the same type of formula. The volume of a prism is always area of face times the depth. Depth means how thick it is. So usually when I think of a prism, I'll have if I have a square face here and a square face there, then they're connected like this. That's what I think of with a prism. We just have a very flat prism. But if you can get the area of the face and you know what the depth is, that's its volume. Well, in looking at this prism, the depth, we're trying to sum up infinitely many, so it's very, very thin. So our depth here is dx, it's a small change in x. So our depth on this one is going to be dx. Okay, then on these, since it's a square face, we're going to have to figure out what that area is, so it's area of a square. But we got to think, are we always going to get the same size square, or are we going to get different size squares? So if we get different size, it's got to have variables in it. So now we know that the volume is going to be -3 to 3 area of a square times dx. So my setup will be the same on parts B and C, except it'll be area of a semicircle and area of a equilateral triangle, because all the slices are perpendicular, so that's always going to be my depth. Okay? So now the question is, what's the area of this square? So here's where I want you to take a second and write a formula for the area of the square. So you know how to do area. Of course, it's of a square, it's length times width. I want you to look at the figure and see if you can determine what the area of the square is. Go ahead. Using a formula. Whether you write it in terms of y or x, I don't care. That final has to be in terms of x, and we'll get to that. So a question, wherever you draw your cross section, is this distance and this distance the same? What do you think? From here to here and here to here, are those the same? Are circular symmetric?
Yeah.
Yeah. So if you can figure out what this is, double it, and that's your length. When you get your length and you know your width or your height, whatever you want to call it, those are going to be the same. Go back to the 5 asterisks I gave you. How do you define big R? How do you define little r? How do you know what the dx or dy is? And then how do you know what x is and how do you know what y is? Okay. So, first thing I would have done is going right here. What is that? So if you're measuring from the x-axis up to an arbitrary point, it's called what? Y. That's y. But that's only half the length. So the total length of this is how much?
2y.
2y. So this is a 2y by 2y squared. Every one of them. So if I want the area, how do you get area? If you know the dimensions, 2y by 2y. Yeah, so want to make sure that we're clear. As I'm looking at this, this here is this. See? If I'm looking, that's this part. And then I can't see the height. It's a certain, it comes out of the wall. It's like sitting out here like this. Okay, kind of molds like this, comes up to a peak like that. It's 2y high. Okay? So if I want area, I multiply these two. So my area is 2y by 2y, which we get 4y squared. All right? So I can sub that in, but we got a problem. I can't mix y with dx. Okay? All right, so just to, again, there's no radius on this unless we use a circle. It's not revolved. It's just sitting here. It's just like a mass. all we're told is if we chop it and look, that's what we'll see. So then I gotta use that information to know how to sum up. So again, what I'm seeing is there's just infinitely many of these square plates in here, thin rectangular prisms or square prisms that I gotta add up their volumes. Now, a couple of things. So we have the equation of this. So we know, what do we know? We know x squared plus y squared is 9. So we know y squared is 9 minus x squared. So I can do what? Yeah, make that substitution. We have -3 to 3, 4 times 9 minus x squared dx. Okay. What else could I do? And now we're done. I mean, this is it. This is your area of the face, and this is your depth. So that's it. That's a volume. We're going to sum up infinitely many of these from -3 to 3. That's what definite integral does. So now all I got to do is integrate, and I'll get the volume of that. However, I could make my integration easier. All right. So would you agree that this side and this side are going to be the same volume? Yeah. So you could go 0 to 3 and double it. The other thing I can do is take this 4 out. So if we go 0 to 3, we can double it. And then if I bring the 4 out, it gives me an 8. And then from there, you can get the answer. We're just going to set these up. And I mean, that's it. Once you integrate, you'll get to the answer. And I mean, we'll do this one, but I won't do the other ones, okay? In terms of working them all the way out. So, if we were to integrate this, so let's see. So we've got 8. So just run it low on room. It's okay. We'll get it right here. 8. All right. The antiderivative of 9 is what?
9x.
9x minus the antiderivative of x squared.
X cubed over
3. And then we go 0 to 3. And we only really need to worry about plugging in our 3 because our 0, I can see that good. We have 8 times 27 minus 27 thirds. So 27 thirds would go back to being 9. And if I can plug in a 0, but it all goes to 0. So we have 8 times 18, which I got 144. Let me know if I'm making a mistake. I got 148 times 18, 144. Okay. All right. Let's look at the next one. So I'm not going to change anything. I'm not going to change my slice here, but I'm going to change what I see. So I'm going to leave this here for a second. Again, this is on video, so it can be paused, and then you can replay it. Again, here's our work. We went here and finished it. So actually, the calculus is not that difficult. It's just getting to that part. Okay. All right. Let's see if we can kind of. But they're all 3 of these are going to be this -3 to 3 volume of a prism. Just what kind of prism? All right. This is if it's circular, it's actually more you would call it a cylinder, but the same idea. All right. So I'm going to leave that and that information up at the top. We'll leave our picture. Okay. So we got 144 for the first answer. That was our volume. All right. Now, here's what's happening. I'm going to try to draw like at an angle of the base. So now, every time you take a cross section, you're going to get a semicircle. So this tells you the diameter of your circle. So smaller diameter, smaller circle. So it's going to try my best there. It's just gonna be like a mound. Okay? So again, the longer this is, that's your diameter, which will then lead to your radius, because it's just a semicircle. So when you slice it, you're gonna see a semicircle like this. Or I see a taco, but either way. We had tacos last night, so. But a very thin, like a very thin taco. Okay, so as if the two shells were touching each other. No place to put anything, any goodies in there. So we get a bunch of semicircular plates. We gotta sum those up, okay? So let's make sure that we're clear. Look at my label. That right there is Y. This is Y, see? So this length here is this. And it just comes to a mound. So this is like a mound here. It's my 3D sketch is not, sorry, I'm in the way. It's just hard to make this 3D sketch. It's just like a mound, okay? All right, so what do you need? You need to know what's the area of this face and you need to know the depth. Well, we already got that. So we need area of semicircle times dx. It's dx because it's a change in x. Okay, if you can figure out that area of the semicircle, then you've got your problem set up. So once you get these set, you're pretty good. Okay, so let's look at this. What's the area of a circle? What's the area of a circle, Ivy? Huh? I'm just asking what's the area of a circle, power squared. Yeah? How much of a circle do we have here? Huh? Power squared over 2. So now the key is we gotta figure out what the radius. Well, radius goes from the center to the out. So I go back to my picture, from the center out, see, because this is taken from here. So that Y is the same as this Y, so what's our radius? Y. We get 5Y squared over 2. Okay? So I'm gonna go ahead and sub that in, even though I know I gotta change it to X's. All right, what can I do with the power over 2?
Take it outside.
Take it outside. What can I do with the negative 3 to 3?
Take it
0 to 3. So we'll bring the power of 2 out. We'll also change our limits to go 0 to 3. If we go 0 to 3, we will then double that. So that'll reduce that to a pi. But you can't mix, right now you cannot. You cannot mix your variables, y with x. So I need this to be an x. So I go back to my equation. X squared plus y squared is 9. So what does y squared equal?
9 minus 6 squared.
Pi 0 to 3 9 minus x squared dx. And if you work that out, you'll get the volume of whatever that figure is. Okay, is that one? All right, what's the last one say our cross section is? Equilateral triangle. What does that mean, equilateral triangle? This is our semicircle one we did. What's special about equilateral triangles? All the angles are 60 and all the sides are the same. So what that's going to change now, again, I'll do my best on the figure here. I'm trying to. So the smaller, so again, like if I have a rectangle here, if I have a slice here, it's going to have a very small height. All right, so it's hard drawing it, but all these triangles lead to the volume, okay? So the main thing I do, I just rely on my 2D sketch. I know if I take a slice and look, I'm gonna get a triangular prism, like a thick piece of pizza. And again, what I do is I take this picture and whatever my Y is, I label my Y over there, okay? Now, Elijah said something important, that every angle is 60 degrees. Because you're going to need some information to help you get the area of this face. How do you get the area? So on this problem, we can see it's going to be -3 to 3 still, but area of a triangle, we know it's equilateral. And we know it's still going to be times dx, because that's my width. So let me ask you this. How do you get area of a triangle? Any triangle. 1/2 base times height. Well, look, you've already got the 1/2 the base. What's half the base? Y. Now what you got to figure out is, what's the height going to be, right? So what I would do is maybe drop a vertical there, right? So I know this is 60 here. But if I drop a perpendicular, what does that turn that angle into? 30. Very good. Now, so is there something special about this triangle here? 30, 60, 90 triangle. So on a 30, 60, 90 triangle, the ratios are known. So across from 60 degrees is square root of 3. Across from 30 degrees is a length of 1, and the hypotenuse is 2. So all I have to do is put those values here, but I know that it's multiplied by y. See, for instance, I need this bottom side to be y. So all I'm going to do is if I multiply each side by y, then that is those are the relationships. You can do it that way. You can do it different ways, but that's how I would do it. Is I know that so take this off. This is this triangle here. Let's go 1, square root of 3, and 2. But I need this to be a y. So if I multiply this by y, then I have to multiply each side by y. And now I've got my height. So my height. So half the base is y. My height is y square root of 3. And so now I've got the area is y squared square root of 3. And that gets subdivided. -3 to 3, y squared square root of 3 dx. And again, we'll probably do the same stuff that we did before. Take the square root of 3 out and double our integral, make it 0 to 3. We know y squared is 9 minus x squared. So yeah, I'll just make this 0 to 3 and double it. And then it's just working those out. Okay? So a couple of things. I kept referring back to the 2D sketch. The biggest thing is do the 2D sketch. So I drew whatever the base was. Then it says cross sections are taken perpendicular to the x-axis, means your rectangle should go perpendicular to the x. So I drew my rectangle, which represents the slice. Okay? And then some basic geometry. Okay?